So, Assalamu alaikum. So the topic that we'll be doing today is integration. Integration is basically the reverse process of differentiation. The first thing that we'll be doing is algebraic integration. Okay. What did we do in differentiation? If understand the entire thing, if I told you to differentiate y is equals to x cubed plus 2x squared, and if I told you to differentiate it with respect to x, so what did you do? Said, okay, dy by dx, that means you were differentiating y with respect
3x
to x.
square plus 2x plus 4x.
3x squared plus 4x. So if I asked you, you differentiated each one of them individually because they were adding up. And the operations that you did were, let me write this down. You multiplied by the power and then you reduced the power.
Power by 1.
Absolutely right. So this was what you did in differentiation. Now, what about integration? If I tell you that integration is the reverse process of differentiation, first understand how would you write it down? How do we write integration down? In differentiation, once we differentiate something, then we call it a derivative. But in integration, before integrating, I need to tell you that, okay, integrate the same thing, 3x squared plus 4x. And how will I tell you integrate this? I've put the integral sign and I'll write dx and I'll tell you, okay, integrate this entire thing with respect to x. This dx is telling me that consider this as a derivative of x and integrate this with respect to x. There is an entire logic behind it, but we don't need to go over there right now. Right now, just understand how do we integrate this with respect to x. Okay, now reverse the operation of differentiation. What should you do first? Reverse the order and the operation both. So instead of reducing the power by 1, what should you do?
Increase the power by 1.
Very good. I'll write add 1 to the power and then divide by the increased power. Is this right, bache?
Yes, sir.
So what will be my integral? My integral will be 3x cube upon 3 plus 4x square upon 2, and then I'll write plus c. Why do I write plus c? I'll just explain that to you in a bit. But the integral will be 3x cube. I'm just writing it in this way so that you understand. The integral of this entire thing is x cube plus x square, 2x square, sorry, plus c. Is this clear? This is how you basically integrate anything. If you write the sign, this is the sign of integral, and whatever is inside it needs to be integrated. And this dx in the end tells you that it needs to be integrated with respect to x. Is this clear? Is this clear?
Yes. Well, so, but I have one question. The same thing that you're explaining. Why do we add C?
Okay, I'm explaining that. Don't worry, don't worry. Okay. Now I want you to differentiate something. Okay. Can you differentiate? If I tell you, please differentiate 3x square. Okay, x cube, sorry, plus 2x square with respect to x. Can you tell me the derivative of this? What is the derivative of this? We just figured it out.
And 3x square plus 4x.
X square plus 4x. If I ask you to differentiate x cube plus 2x square plus 8 with respect to x, what is the derivative?
3x square plus 4x.
3x square plus 4x. And if I tell you to differentiate x cube plus 2x square minus 5 with respect to x, what is the derivative?
So 3x square plus 4x.
3x square plus 4x. In all cases, you differentiated it and this is what you got. Is that right? What happened
Yes.
to the constant while you were differentiating? What actually happened to the constant?
Its power became.
What happened to the constant? It is eliminated, right or wrong?
Right, sir.
All of these expressions were differentiated and all of them gave me the same answer. But are all of them the same expressions initially? No, they are not. So while I'm integrating, I need to make sure that I need to accommodate for the arbitrary constant. It's possible that there is no constant, so no need to worry, my value of C will be 0. But if there was a constant, and how will I accommodate that? I will accommodate it by adding a C. Is this clear now?
Yes, sir.
So that is some very basic integration that we can do. Again, if things are adding, we can simply integrate each one of them individually, and that is how we will want to integrate right now. So this is the very basic of integration. We'll try to do a few questions regarding this and understand it. I'll try to explain the very basic operations as well. We'll take a few questions from exercise 15.1 and we'll try to attend that. Okay, now the question says, can you see the screen, Bache?
Yes, sir.
Okay, now the question says find y in terms of x for each of the following. I know when I differentiate y with respect to x, what do I get?
dy by dx.
So if I'll integrate dy by dx, what will I get?
Y is equal to x.
No, I'll get the function y. If I differentiate y, I get dy by dx, right? So if I'll integrate dy by dx, I should get y.
Yes, sir.
Is this clear? So I'll get y. Let's see how do I write it. If I integrate, what do I integrate? This entire dy by dx with respect to x. Is this right?
Yes, sir.
How did I get all this? Sir, you got this when you differentiated y with respect to x. So if I integrate this entire thing with respect to x, I'll again get y. So let's try to get y. What is our y in this case? 7x to the power 7 upon 7 plus 2x to the power 5 upon 5. How do you integrate 3? What is the integral of 3?
The 3x.
Well done. 3x and then plus c. Remember, without the plus c, the integral is incomplete and hence it is wrong. Is this clear, Bete?
Yes, sir.
So this is your complete integral. Can you integrate the second one for me? You integrate it. What do you get? Understand the notations as well. What does this mean? I am writing that I'll get y once I integrate this entire thing with respect to x. So how will I get y? 2x to the power 6 upon 6 minus 3x to the power 4 upon 4 plus 5x square upon 2 plus c. So y is, you just simplify it for your own ease, because if you need to use it in future, you must have a simplified integral or function. Is this clear?
Yes, sir.
Okay. Let's try to do part C and D as well. Yes, bache. I'm waiting to attempt the two parts and then I'll discuss. See, first, I'll just simplify the derivative so that I can integrate it easily. Now remember, this is still my derivative. I haven't differentiated it yet. But now, if I integrate this entire thing, now this looks like an integral form. So I increase the power by 1 and I divide it by increased power. And then I increase the power by 1 and I divide by the increased power. So now we can just simplify. This is minus 1 upon x cubed plus 15 over x plus x square over 2 and then plus c. Is this clear, Bete?
Yes, sir.
So we did the same thing when we started with differentiation, right? The very first part of differentiation, when we were getting simple algebraic functions in the denominator, we were just bringing them in the numerator and trying to differentiate them, right? So the same thing we'll do in integration as well. Is this clear now?
Yes, sir.
And the next one. Let's see. So you're telling me y is, what did you get?
So minus 2 upon x power 9
Okay, minus 2 upon x power 9,
minus 1 upon x power 6
1 upon x power 6
minus 2x.
plus c. Good. So this is something that we have taken care of. This is very easy. Just we'll do a bit more, a couple of more parts maybe, so as to understand. For a very long time till you go to A2 level. Again, you still need to find y in this one. This is question number 3. You won't be having any product or quotient tool for integration. So be very clear about it. Do not even think of intending to produce a quotient or a product tool. Get to some part of it will be covered in A2, but nothing before that. And how do I integrate this one? Again, same problem. First, let's just simplify the derivative. X to the power 5 over 2x cubed minus 3x over 2x cubed. Now, still the derivative is written as x square upon 2 minus 3 over 2 or 3x to the power minus 2 over 2. Now I can integrate this entire thing, and I know when I integrate it, then I can call it y. So I'll say x square upon 2 minus 3x to the power negative 2 upon 2. If integrated with respect to x will give me y. This is what this entire thing means. Whatever is inside this integral symbol has to be integrated to give you
Sir,
y.
do we have to add the integrated symbol?
Obviously, how else will you show that, okay, sir, we got this? When you differentiate something, don't you write d by dx or dy by dx or dy by dt?
Yes, sir.
Show that you differentiated it, right? That becomes a different thing altogether. So you're showing it, I will integrate this and then I'll call it y. Is this clear? So understand the notations as well. The notations are also something that is new to you. So this is x cube upon, again, same thing. When you divide by 3, you get 6. And then minus 3x to the power negative 1. When you divide by negative 1, this becomes negative 2, and then plus c. So y becomes x cube upon 6 plus 3 over 2x, and then plus c. Is this clear?
Yes, sir.
I'll just share the last two parts as well. Can you attempt the remaining 3 parts and then I'll discuss it? Again, we'll first try to simplify the derivative. So we cannot integrate it because it's multiplying and then it's dividing. So let's just expand the numerator. 2x squared minus 2x minus 3x plus 3. And now I'll just say,
Can't we just
I told you there is no product or quotient tool in integration, right?
yes, sir, but we can also make
yeah.
two denominators by 2x minus 3 upon x power 4 and x minus 1 upon x power 4.
Right, but what will happen to those two fractions then? You cannot write x power 4 with both of them. You cannot do that. The brackets are multiplying. They're not adding up. If they were adding up, you would have been able to separate each of them.
That's the reason I was getting.
No worries, no worries. Now see, now I can separate them because they are being added up. Is this clear now? Now can you integrate it? Now, does this look integrable to you?
Yes, sir, it does.
Please do it and let me know what do you get and attempt the next few parts as well. Told you integral is incomplete without
Plus C.
exactly. If you're not telling me the constant, next time I'll tell you that the answer is wrong. So, so if you do not include the arbitrary constant, I'll just call it down to x. So that becomes minus 2 upon x, and then plus 5 upon x squared, and then minus.
So 5 upon 2x4.
Yeah, divide by the increased power. Sorry, you're right. 5 upon 2x squared minus 1 upon x cubed plus c. Is this right?
Yes, sir.
And now attempt the next two parts. X to the power 5 over 2x squared minus 4x squared. So dy by dx will become x to the power 3 upon 2 minus 2 plus x to the power minus 2. Now I can get y by integrating this entire dy by dx, which is x cubed upon 2 minus 2 plus x to the power with respect to x. So y will become x to the power 4 upon 8 minus 2x, and then this will become minus 1 over 2x plus c. Is this right? Is this what you're getting? Yes, Bachir.
Yes, this is what I'm getting.
Let's do part edges with we just like
And the numerator.
first let's just expand the numerator. Apply 3x into 3x squared
3x squared
plus
minus 6x plus 5x minus 10. And then you simplify it is equal to 3x squared minus x plus or minus 10
and the entire thing.
upon x power negative
Yeah,
x power 1 2.
even that is fine. X power half minus x upon x power half minus 10 upon x power half. Now I can write each one of them individually, which is 3x to the power. If I take 2 and I subtract 1 from it, I get 3 by 2 minus x to the power 1 by 2 minus 10x to the power negative half. Now,
Sir, don't you get negative 1 upon 2? 2 minus 1 upon 2.
subtract 2 minus 1 upon 2. You'll have to take the LCM. We can use a calculator to do that as well, Vijay.
It's 2, sorry, I thought it was 1.
It's 2.
My mistake.
So it's perfectly fine. So now integrate it, increase the power by 1 and divide by the increased power. 5 upon 2 and we divide by 5 upon 2. Obviously, I'll write it in a better way, but just helping you understand. 3 upon 2, then minus 10x to the power 1 divided by 1 upon 2, and then plus c. So now I can write it as 6x to the power 5 over 2 over 5 minus 2x to the power 3 over 2 over 3, and then minus 20x to the power half plus c. Is this clear now?
Yes, sir.
This is how we integrate. Let's just do a bit the next question of the same exercise, question number 4. Now we understand how do we get C so that we can attempt the remaining parts. Okay, same thing. Now the question wants us to find the actual equation of the curve. How will we do that? We'll say if we integrate it, we get y, right?
Yes, sir.
So 3x squared minus 4x plus 1. When integrate with respect to x will give me y. Let's integrate it. 3x cubed upon 3 minus 4x squared upon 2 plus x plus c. Is this equation of the curve?
Yes, sir.
Now, how do I get the value of c? The question is provided me with a point that is on the curve, 0, 5. So can I just plug in those values in the equation of the curve?
So what are you trying to find?
C. Because
Yes,
once
sir, we
the
can.
value of c, then I will know the actual equation of the curve, right?
So 5 is equal
Value
to
of
6,
c is
5.
5. So the equation will become x cubed minus 2x squared plus x plus 5. Is this clear now?
Yes, sir. So that's why C is important, or the 5 would be high.
Exactly. If there were no c, nothing to worry about. We'll get the value of c as 0. We are not too much worried about that, right? But we need to accommodate for the arbitrary constant. Even if its value c, it will be eliminated on its own. Is this clear?
Yes, sir.
Can you attempt this one on your own?